Yes, so today we are going to study microscope. So first of all, what is microscope? Microscope is an instrument that gives you an enlarged image of object which you can't see from the naked eye. Okay, that image is like basically the image we cannot see from the naked eye, like bacteria, virus. So to see that we use the microscope. Okay, so now here we have two types of microscope. Number one is simple microscope, while another is compound microscope. Okay, so first in this video we will discuss about the simple microscope. So let's see. In simple microscope we use the one convex lens, or you can say the biconvex lens. Okay, lens, or you can say as or biconvex lens. Okay, so now we have convex lens. Okay, so I'm drawing this principal axis. Here we have focal length, and this is a convex lens, and here we have human eye. Okay, so now the object will be placed between the focal length and lens. Here, for suppose object is placed. Okay, so now object will move over this. We will see from the neck eye, and from here the object will pass over here. So see, these both lines are parallel to each other, so we cannot see the image. So what, they will meet at the any point. So they will meet at this point. At this point they will meet. So now here we can see the object properly. So let me tell you procedure what happened here. First of all, this is we have convex lens and the object is here. So now the ray light come and move to the eye. So this is parallel to the lens. Then we have this line will move from the optical center, this optical center, and passes at the same path. Okay. Okay, so here you can see these both lines are parallel and they will never meet. Okay, so for the image formation, the lines must be meet. So we will move backward and we will make the line to be meet. So here the line is meted to form the virtual image. So here the virtual image is formed and we can see from the eye. This is the enlarged image. Okay, so here we have when the object is placed between the focal length to the lens, so the image will always form the virtual image will form virtual, erect, and magnified. Fine. Okay, so you can see here the lines do not meet at this point, and for the image formation the lines we need lines must be meted. So at the back line will meet and form the virtual image, that is enlarged image, means magnified image. Okay, so this is basically the position of object that which is placed between focal point and lens. So this is we have position of object. So now let's discuss about the position of image. So where image is formed. Okay. So let me write here position of image. So you can see here the image will be formed. Image will formed at the near object, near point. Near near position. Like near position what? So the distance from the human eye clearly without wearing the lens of convex or concave, the human eye can see the clear and sharp image at one distance. A clear and sharp image at the distance. Okay, so that distance is known as their distance, or that distance is basically 25 centimeter. Near distance is 25 centimeter. From at the 25 centimeter distance, the human eye can see the clear and sharp image, and that is also known as least distance of distant object, that is 25 centimeter. Okay, so this distance is the minimum and maximum distance from which we can see the clear and sharp image, 25 centimeter. So now let me tell you about nature of image. Like what is nature? As I told you, this is virtual, erect and magnified. Okay. So now here the question arises that how much it can be magnified. So let me tell you like how much. Okay. So to identify this how much the image is magnified, we have formula that is m is equal to magnifying is equal to theta dash upon theta. Now to identify this, let me make two diagrams. Like here object is placed, this is human eye, and I give name as this is O and I. Okay, and here we have theta, and the distance as we can see as 25 centimeter. Now let's do another diagram. So here we have another diagram, like this is the object, and here we have the lens we use here, and this is the human eye. Okay, so now here we have like I give the name this as I and Q, and here we have theta naught, and this point, this is the focal point, and object is placed between the lens and the focal point. So that object I give name is Y, O and I, and this is distance. Okay. Okay, so this diagram basically like here we have human eye and this is object place. So now we need the enlargement image, like we have to see the magnified image. So to see the magnified or enlarged image, we use here the convex lens. Okay, so now here this is the theta naught and this is theta. Okay, so now here we will use the tangent theta. Tan theta. Why we use the tan theta here? Why not sine and cos theta? Because as we are measuring here This is we have base and perpendicular. Here is the known work of hypotenuse. So as we know, where the base and perpendicular we have in tan theta. Tan theta is equal to perpendicular upon base. Okay, for that we have applied the tan theta. Okay. So here tan theta we have like tan theta, like here we have perpendicular we have O I and base we have D, distance. Okay, and in tan theta naught we have like we have perpendicular I and Q, while the base we have D, distance. Okay, so as we have that formula, that was m is equal to theta naught upon theta. Okay, so the value of theta naught was I upon Q upon D, and the theta value was OI upon D. So if we will move this value here, so it will means inverse. Let me put over here IQ upon D, and this will be inverse D upon OI. So DD will cut over here, distance cut. Here we have I upon Q and OI. Okay, so now let's move forward. So here this is we have image size, and this we have object size. Okay, so here we use the formula that is size of image and size of object is equal to distance of image and distance of object. Like these both are equal. Like size of object we have 3, then size of image means magnified image we have 6. 3 1 the 3, 3 2 the 6. This will be 2 centimeter. And talking about distance we have 6, and the magnified we have 12. So 6 1 the 6, 6 2 the 12. This will be 2 centimeter. Okay, so here both are equal to each other. So now for this we have one formula Q upon P. Why we use Q here? So the D, as I told you, the distance for between the image. Here we was having image. Here it human eye, and here we have focal point, that was image virtual. Then making the image virtual. This was virtual. So this was the distance. So D is also represented by Q. Distance is represented by Q. Okay, and we have the object, which we have placed the object. So that object is also represented by, and object is represented by P. Okay, so now so here D is represented by, as I tell you, Q is distance represented by Q, and here we have P. So this is D upon P. This is the formula of magnification. So now let's move forward. Let's do with the length equation. So this is what we have, the length equation. So now we have the distance. So let's multiply the distance on the both sides. Multiply D on both sides. So it will be D upon F is equal to D upon P. Minus. Why minus? Because if the image is virtual, so as I told you previously, in virtual the image, the distance is always in minus. Minus. Okay, so minus, and we have last one is D upon Q. Okay, so what was that? We have D upon F is equal to D upon P minus D upon Q. Now as I told, like put here D upon F same, and this is what we have magnification, formula of magnification. So we will put here M minus, now D and Q is represented by D, so D will be cutted, and that will be 1. So here we have we have the form. Sorry, here we have the -1. So minus will move here, that will be the +1 plus d upon f is equal to m. So this is formula of magnification, how the enlargement is.